Hello everyone, welcome back. So today we are going to implement remove first in our singly linked list implementation playlist. So the format is same. First we will do the coding, and then after that we will come back and then we will execute on a whiteboard, and then we will discuss about the time and space complexity. So function declaration will be fun remove first return t. So there it depends how you want to implement. So for now I'm implementing in a way like if it's empty and someone, my client will call this method, I will return null. If I have a value, I will return the value and remove that node. And the third option is I can throw an exception. If I will throw an exception, in that case I will return confirmed value. So in that case, for example, if I'm returning a confirmed value, in that case I will throw an exception here by saying, okay, if my list is not empty, then return. If my list is empty, then throw an exception. So it means client is responsible in that case to check before calling remove first if it's empty or not. So it totally depends how you are going to design. Okay, so for now I'm taking care of this. So what will be the next step is, so only try to think we have a list, and is there any edge case? uh, there are edge cases. So what can happen? Okay, first edge case, if it's empty and the client call the remove first, what will happen if we have two values? So it means we have a first is head and the second is the tail, because the second is last. Then we need to take, in this case, are we need to take care of tail? I don't think so, because head will remove and it will move towards the tail. And anything else, in case of we have only one, so it means head and tail both are on a pointing to the same node, and if I remove that, I need to update the head. So there is one edge case to take care of the tail, and there are multiple options how you want to implement. You can go by checking the head is not equal to null, tail is equal to null, around that, or you can play with the size. So I'm going to choose size because it look more easier and more readable if someone is not very good with the pointers or the like the linked list. So what will be first thing I need to check? I need to check if size is not equal to 0, or I can say the better approach will be greater than 0. But for now, okay, so if that is true, then first do size minus minus. This is pretty important. Or we can do one more thing. So we can create a one method which I need to make later, but now I can do now, and that is empty, just like we created one inside of our array list implementation. So basically is empty. Maybe I can make this as a public method, so anyone can use. And I will say if it's equal to 0, yes, it's empty. And this is a Kotlin way, but I can change to this more like the Java way. It will be easy for. So return. This is done. Now in this case, what I'm saying okay, if it's empty not, okay, then you need to do size minus minus. Now size is done. Next I need to take a value which I need to return, which will be type of nullable t, and that is my heads value. So in this case, if it's null, like my list is null, value will have null, and I need to return this value at the end. Okay, this is done complete. In case next step will be head move to its next node. So in that case, if its head is already null, for example, in this case nothing will happen because it's a null to null. And now we need to think about the tail. So for case of a tail, I need to do only one thing. If we have only one member which I removed, I need to update tail to the null. So in that case I can check again if is empty, which means we before that we have only one value and size minus minus 2 0, so now it's empty. So it's a case in which we have only one value in our linked list. So in that case tail should be now equal to null. I hope you understand. Like for example, if I have two values, in that case, what will happen? Size is 2, is now 1. I will return the value. I will move head to the next node. So my first node is now basically the next node, the second one, and head is already removed. And we will do nothing with the tail because tail is still there. We are not moving anything. I will show you more on a whiteboard this. Only one concern. So once we move our head to the next node, I think the previous node's next node still pointing to the second node. So yeah, we can't see that value, but I think so that is still in memory. So I think we can do kind of something like this: value temp equal to head. So head is moved towards the next, and then I should do next temp dot next node equal to null and temp equal to null. Or if in case this is value temp, if I don't do temp null, once this function is complete it will automatically ready to garbage collection. So I think uh, we are done with our remove first. Now we can try with some examples. So we already have this list. So we have 1 2 3 10. We can see how our list looks like now. So it's showing 1 2 10 3 and null. So if I ask remove first, so what will be that value? I want to print that. Second, print the list, and also we can check to create a empty singly linked list with integer. So in this case we will see what will be the output. So first we print this one, then after that saying okay remove first is giving me 1, then I have to make sense because our list now start from here, and the last one is already returning null. And if I'm writing test, I will recommend if you write test, that will be great. And if I call this, for example, like more than how many elements I have, then we will see what will happen. This should return null 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 null. Yes, and in the end this list is somewhere here, but it's showing also empty or null. So I think it's working according to our expectation. Now we can execute some scenarios. So for example, client created a list and which is empty, and he called directly list dot remove first. So I can make a list of, so we have a head and we have a tail, and both are pointing correctly to null. So in this case what will happen, once we will call it remove dot first, if you remember, it will call first if is empty. So it's empty, yes is true, so there will be no size minus minus, and then it will move toward the head, get the null, and then value is null, and then taking temp again playing with null, and in the end checking if is empty, tail make null, and then return null. So there will be no, there are some operations but they are not going to impact anywhere. Now for example we have a list like this. So I have a value 1, simple. So my tail is there, head is there, and my size is currently 1. So once we call this, size minus minus will do this 0. Then heads next basically will move towards null. Then we have a temp is also null. Then we are coming towards the reading the code where we write if is empty, then do tail equal to null. So now is it empty? Yes, our empty method is size is equal to 0. So tail is also going to be null, and then we will return 1, and this is done. Second scenario, maybe what we can do, yeah, I want to do 2 more. So we have 2. So for example, we have a list of 2 values, 1 and 2. In this case, my head is this, my tail is here. So once the client is called remove, first we will do size minus minus, which will be 1. Save this 1 in a value. So now this 1 is a value. Then I am taking temp, which is also doing here. Then head is going to the head to next. This, so there is no more. Then I'm saying okay, temp the next should do null. So this one is now not connected to this, so it's ready for the garbage collection once the execution of this method is complete, because temp is in a method. So temp is automatically garbage collected. Once this is garbage collected, there will be no more reference. And then in the end, is empty, if is empty. So currently we have size is 1, so it's not empty. Don't do anything with tail anything, and then return 1. So in this case, basically what happened, now we have head here, so now we have only 1. So if I call again, this is the same case which I already executed. Then the last case in which we can execute, maybe we have 4 values, so that will be enough. So this is our last case. There is no need to execute more than this. 2, 3 and 4, and this is our tail. So remove first is called, again the same thing, temp is coming to this, then this is going to be 3, head is moving towards here, tail is removing this, then return the value of 1, and then method complete, garbage collection. Now we have head, so we are doing nothing with tail because is empty is 3, and in our case the tail will not be equal to null because this is not empty. Now the final thing, what will be the space and time complexity? So we can discuss time complexity. Space complexity is still same. Head, tail, we are taking one temporary pointer. In case of a time complexity, what happened, we are doing every time the constant operation. So we do size minus minus, then after that I'm saying okay, move head to the next. Then after that I'm removing by using temp. Then I'm again checking remove the is empty. If it's empty, make tail equal to null, and then return value. So all the instructions or the operations are constant. They are not dependent on the number of elements. Yes, there are if check which will be executed against that the if is empty, but still if I have n 100, like 100 elements, 3000 elements, 1 million elements, the time of this function will be same. So we can say it's a big O of 1. So I hope you enjoyed today's session. See you in the next one. Bye.